Hi guys, warm welcome on German's MATLAB coding. In clip 12, we are going to address how one can graph multiple datasets. In clip 11, we mentioned that embedded function plot can graph single dataset. If we have multiple datasets, embedded plot can also take care of that. Suppose we have two datasets, xy1 and xy2. We can graph it by calling as plot of x comma y1 comma x comma y2. In the case we have three data sets x y1 x y2 and x y3. We can call the plot as plot of x comma y1 x comma y2 x comma y3, and this way we can extend this function for four or more plots. One thing to be pointed out, all these x, y1, y2 are identical size row or column matrices. Let us see the example one in this regard. Here we have a tabular data. We have x data, we have y1 data, we have y2 data. These are some discrete data. We'd like to graph y1 and y2 versus x. Very simple. Go to MATLAB command prompt. Enter all x data as a row matrix to workspace X as shown on the screen. Enter all y1 data to workspace variable y1 as a row matrix. Enter all y2 data as a row matrix to variable y2. Then call plot as plot of x comma y1 comma x comma y2 and then press enter. Successful execution of the last four statements should show us the graph as seen on the screen. There are two trajectories, first one for y1 versus x and the second one for y2 versus x. The blue one for y1 and the red one for y2. Horizontal axis variation is x and vertical axis variation is either y1 or y2. In example 2, we have two functions y1 and y2. We would like to graph these two functions over common x variation. Here x variation is 0 to 20 and our step size for x is 0.05. So in earlier clips we mentioned that scalar code computes a function. So go to MATLAB command prompt, generate the x vector from 0 to 20 with increment 0.05, assign it to workspace variable x. Then go to the next command line and calculate the first function y1 by scalar code and assign it to workspace variable y1. Then pressing enter, you go to next command line, calculate the quadratic function, assign it to workspace variable y2, and call the plotter as plot of x comma y1 comma x comma y2. And the return from MATLAB you see on the screen. The blue curve for the first one data which is y1 and the red curve is the second one data which is y2. Horizontal axis x, vertical axis y1 or y2. In example 3, we have three data sets for y1, y2 and y3. We would like to graph these three data sets over same x variation. Okay, go to MATLAB command prompt as a row matrix, enter all these data sets, first for x, then for y1, then for y2, then for y3, and after that you call the plotter as plot of x comma y1 comma x comma y2 comma x comma y3. And the three curves returned by MATLAB, no surprise. The blue one for y1, the red one for y2, and the constant one for y3. Referring to the last graph, we have three traces, and there is no way of knowing which graph stands for what. We can distinguish different graphs using embedded function legend, but the legend has some syntax. If we have two traces, we use two user-defined texts. If we have three traces, we use three user-defined texts, and so on. And the text is placed under single inverted comma or quote as seen on the screen. Let us practice the legend on the last graph. We have three graphs, so we need three texts. For the first graph, we have chosen the text y1 graph. You could have chosen another text. After running the statement in MATLAB, you're gonna see the output as shown on the figure. Here, upper right corner shows you the legend inside the box. The color code of the legend easily can distinguish different graphs. Okay guys, bye for today. Hope to see you another day.